The door. We're going to talk a lot about secrets. We don't want the secrets to go out. Cool. Good afternoon. Everybody having a good Ignite? Fantastic. I know you had a lot of options competing sessions, but thank you for coming in today. And you're going to be going with a lot of good information. And this track, the goal of this presentation is to talk about the innovations that we are doing around open source databases on Azure platform. It's not going to be about all the features of the managed service and talking about each and everything in detail. This is really about telling you what we have done, how are we innovating, what are the themes that are defining those innovations, and give you a glimpse of things that you have not heard about at Ignite today or you will hear this week. So I want you to take away some of what we are doing now that will come out in a few months, and maybe 6 to 12 months, right? So that's the goal of this session. And for those that are wondering why you're here, of course you're here. Now that you're here, and then what you want to take away, and then pass on this message to others, I want you to lead with 3 facts. Right? Open source is the future. And why do I say that? And especially when I talk in the context of relational databases and open source databases in particular, 3 statistics that I want you to pay attention to. Number 1, Gartner predicts by 2020, more than 85% of the new applications will still continue to be using relational technologies. Right? Who said relational is going to die or NoSQL is going to take over relational? It's not about who is dying and who is winning. Both of these choices, technology choices, are being increasingly harvested and leveraged by developers, by modern developers as they're building new applications. Second, even more reason why you're here today. By 2022, more than 70% of those new in-house applications will be using or leveraging open source database management systems or cloud-based open source managed database systems. This is from the 2019 Gartner, the wave that we get reports on based on how the industry and how enterprises are embracing this. And finally, it's always good to predict, but it's also important to know where we are. What is happening against this? We're talking about next year and 3 years, all of these 70-75%. Where are we? The recent report from the cloud, the RightScale 2019 State of the Cloud report says relational database managed service in the cloud is the top workload. And over 53% of the users are using DBaaS in the cloud. It's the number 1 workload in the cloud. So now if you round up all of these 3 factoids together, you know why you're here and why it is important for you to know what Microsoft and Azure is uniquely doing in order to deliver on these new trends and deliver on this momentum happening around open source and relational databases in the cloud. What are these open source relational databases, you may wonder? Hope not. But the 3 most common relational database engines in the market is MySQL, Postgres, and MariaDB. MySQL is by far the most used open source relational database in the industry. Given its heritage being part of the LAMP stack and shipped in every Linux that went on, that got distributed, is one of the most highly used database, mostly in the packaged applications, whether it be content management systems like WordPress or Drupal, or e-commerce management systems like Magento. It's being used by enterprise mission-critical workloads. There are many significant customers that are using today these services on Azure, right? The e-commerce platform of one of the top retail, for example, Nestle, is using Magento and MySQL on our platform. Postgres is continuing to become the most loved and wanted database. It's grown in its popularity. It's one of the most robust feature-rich, and extensible database technology in the industry today. It's a very good target. It's one of the favorite database to use for Oracle migrations because of its capabilities like PL/SQL. And also the rich extensions and the data types that it supports, like JSON, JSON-B, time series data, allows developers and gives developers the rich set of core database technologies for them to build powerful applications. And finally, MariaDB, it's growing, but it's not there as yet as where MySQL or Postgres is. It's an open source, and we are committed to open source, and is the reason why we are continuing to innovate and develop our innovations also with MariaDB. But so by far, we see from enterprises, from businesses like yourself, MySQL and Postgres are the most predominantly used database engines. What are some of these workloads? What is driving the demand for these open source relational workloads? The digital transformation, the transformation where businesses are looking to extract value from the data to use it for strategic competitive differentiation is happening in open source. And the key difference being that this innovation, this disruption is influenced and driven by the developers. And developers love easy access to free open source technologies. And it is also a very low-cost approach to drive innovations without having to bet on many proprietary technologies and paying immense amount of licensing costs. Secondly, a lot of these ISV applications, for example, those ISV applications you may be using today in your enterprises, as they are looking at modernizing and getting onto the cloud as a SaaS, they are increasingly using open source databases because they want to be able to serve these applications across the clouds, across multiple clouds. And therefore, they choose open source database as a building block to build that application. Adobe was one of the fine example that standardized to use Postgres as their database of choice for their campaign marketing platform. Third, modernization from Oracle and looking at cheaper open source counterparts, and Postgres is emerging as the favorite engine to migrate to. And then a lot of these gamification and these new cloud gaming applications are increasingly being built using LAMP stack, and MySQL is becoming the database of choice in these modern game workloads, also in the defense gaming scenarios as well. And finally, the most important point, and which goes back to the previous comment that I made, that this is not about MySQL versus Postgres versus NoSQL versus SQL database. These modern applications are increasingly being developed using microservices-based architecture where they are componentized, and developers are choosing, and we are seeing developers adopt the right technology for the right component. So we see application patterns where these multiple databases are being used for the different services or components. Maybe MySQL for the metadata, maybe Postgres for real-time operational analytics, maybe SQL database for transaction processing. And then sometimes we see NoSQL like Cosmos DB as well. So it's not about what we see is really a polyglot environment where these microservice applications are using multiple databases and using the right database for the right workload so that they can get the best of the performance, the availability characteristics, and then also reduce their overall costs. So how are we executing on our managed database services? So we call the foundation building block on which we support and which we provide these managed services, we call it as the Azure, like the Relational Database Services Platform. It's built on the standard Azure compute storage and network, and infrastructure that is spread across 54 regions. Then, of course, what do you expect when you come to a managed service? Right? You want the managed service to take care of all the backup, patching, give you the controls, give you the security controls, support migrations, monitoring, alerting, all that good stuff, right? All the mundane operations that you are used to doing, you want it available as a turnkey operation. Every cloud provider, including us, do a very good job, a decent job, in providing this fully managed capability so that you, as a developer or a DevOps, doesn't have to go do these things and manage these things by yourself. We do the same thing, but we go above and beyond. And that's what I want to talk about, and that the innovation theme that I was talking about earlier, that's what I'm going to be addressing towards the next part of this presentation. Our database services platform, for example, when you as a developer or a DevOps want to migrate or take away your existing workload or build new workload in the cloud, it's not about just the motivation of converting from CapEx to OpEx budget. Because the example is very similar to leasing or buying a car. Because you know that when you're leasing, at the end of the day, you end up spending more than if you hosted your databases on your own hardware and then amortized it over 5 years. Why come to the cloud? You come to the cloud to get the true benefit of elasticity. You want cloud elasticity to your workloads. You don't want to spend expensive dollars on over-provisioning. You want the right capacity at the right time. You want the managed services platform. You want the cloud to do something that you could otherwise not be able to do on premises. The benefit of operating and managing millions of databases in the cloud allows us to do unique things and add value to you that otherwise you would not be able to. Otherwise, why come to the cloud? Security. We all know security is of paramount importance, and that includes privacy. It's not about just creating and providing you with the control knobs on how you manage and govern your security. It is going above and beyond. What else can we do? Because now you're in the cloud, what else can you get coming to the managed platform and use these databases? That's what we obsess about. And that's what we continuously hear the concerns from developers and DevOps and enterprises about how are we going to solve these core problems. And then about hyperscale, because traditionally there is a belief that open source databases are good for 1 gigabyte, 10 gigabyte workloads. What happens if my database size is 5 terabytes? What happens if it goes to 10 terabytes? What happens if the processing, if the number of concurrent users to my database goes beyond thousands? What should I do? Should I then go and do some costly refactoring and then move to a SQL database, or do I go to Cosmos DB, or do I go then refactor and go to some other proprietary technology? Making sure that when you take a bet on these database engines, we have you covered so that you don't have to go through this expensive refactoring anymore. That's where Hyperscale comes into picture. Hyperscale provides you with capabilities that allows you to scale across compute, memory, and storage. So that when you take this bet on these database engines, we have you covered wherever your workload takes you, regardless of how many of our cores, how much of our memory, how much of our storage. You never have to think about refactoring or changing your application just to get the scale and the performance as the workload demand increases. That's what we provide as a fully managed service on Azure. The Azure Database for MySQL, Postgres, and MariaDB takes these fundamental themes and innovate beyond just delivering fully managed service capabilities or providing you with turnkey ability to enable replication, monitoring, alerting, patching, and so on. So before I go further, along these themes, we made a major set of announcements at Ignite this week. We announced the general availability of Azure Database for Postgres Hyperscale. We'll talk a little bit more about that as well. And then also for the single server options, we introduced reserved instance pricing. So you can now save money by reserving capacity. We announced general availability of scaling storage on single servers to 16 terabytes and 20,000 IOPS. We announced integrations as well because we believe as developers are building their applications on our platform, it is not just about the database. It's also about the capabilities that we can provide to improve the productivity of those developers so that they can get the best out of the Azure platform and the Azure ecosystem. And towards that, we announced support for Power BI Directory. Now, Power BI Directory allows you to offload the query directly to the database so that you can get those reports on Power BI at very high speed and high scale. And similarly, to strengthen our enterprise security, to strengthen the security controls, we announced integration with Azure Active Directory. So now you can have your centralized user ID role management in Azure Active Directory and centrally control all the authentication and access to your database. And then finally, we also announced, we made a huge announcement this week by Satya and Jason about Azure Arc. And with that, we also announced availability of Hyperscale Citus on Azure Arc. That means no longer are these innovations and all the differentiations and the themes that I talked about is not limited to Azure anymore. It's extendable to wherever your infrastructure is, whichever cloud it is, whichever like on-premise. You just bring the infrastructure and Kubernetes, managed by Kubernetes, and then all these capabilities are available to you. All these innovations are now available to you. Okay? So now let me start walking these themes one by one, and then we will have rich demos talking about these capabilities as well. First, as you think about your managed databases, your need is that it's highly available all the time. It's not an optional feature. Unlike hosted managed services, where availability is an option, whether you can choose whether you want availability or not, we believe availability should be there all the time. Performance optimization. How can you maximize and make sure that you're getting the best out of your resources? How can you gain insights from your workload so that you can take specific actions on them? Enterprise security. We believe we will be never ever done with security. It will always be one of the core premise on which we'll innovate and continue innovations. Use Azure anywhere. Bring the best of what you get between Azure anywhere you want and also across all the global regions that Azure supports and continues to expand. Including this past week, we saw and heard Jason talk about availability of Switzerland and Germany. We are now available in Switzerland and Germany as well. We announced expansion to Norway, and we're going to be in Norway as well. And then finally, improving developer agility. That is about how can you bring the best of the developer productivity across the ecosystems. And here, we are not talking about just integrating with the ecosystem of Azure. As Azure is increasingly getting more and more of these open source stack and open source workloads, we are uniquely able to provide integrations not only with our Azure ecosystem, which is proprietary, but also the open source ecosystem. First, let me talk about a little bit about the high availability. We have a unique services architecture that provides and that allows us to give 4.9 of SLAs availability on single databases. Have you heard about high availability without replication? Has anybody? Can anyone raise their hands? No. But that's how you think about defining availability in the cloud. This is bringing the cloud-first principles to our design, where by using a secure container-based technology that provides full resource isolation and resource control, and optimizations to detach and attach remote storage, we are able to provide this availability and therefore significantly reduce your costs. And this is how it works. So you have your MySQL database or a Postgres database going down. What happens next? We can spawn a new container in less than 2 seconds. We detach the storage from the old, attach the storage to the new. And this is not running on a Docker container. It's running on our own secure container technology. And that's the innovation piece at the platform, at the guts of the platform, which is not really transparent to you, but I wanted to kind of give you an insight into how we go about doing this and how we think about availability in a non-traditional way. In the traditional way, you would set up a replica, and then you have a sync replication and then fail over. That's the usual practice that we have all grown up and known how to do HA. This is a new modern cloud-native way to implement high availability. Similarly, a storage copy goes bad, we are able to automatically reconstruct and always keep 3 copies of the data. No application impact, 0 impact. How does elasticity work? We talked about cloud elasticity. How many of you, if you're running your databases on a virtual machine today, because it's virtual machine, and scaling a virtual machine usually takes minutes, 4, 5+ minutes. That's not elasticity. Elasticity is something that you can measure without major impact to the application. Right? So the same underlying architecture that powers our high availability also powers elasticity. You scale your compute, a new container is created, and we detach and attach the storage. No longer you have to keep your resources over-provisioned for that 1 day a month, or 1 day a quarter, or 1 day a year of reaching that peak capacity. You can right-size and get the right resources at the right time so that you can optimize on your costs, which makes running on a managed services cheaper than running on a virtual machine. That's what we mean by innovations. We disrupt the way these databases are run on the cloud. Okay? Let me talk about some of the intelligent insights to optimize our workloads. These capabilities exist to give you or arm you with insights that you can use to actually make impact or change the application. First is Query Store. What is Query Store? Query Store is an ability where it stores all the telemetry, all the data related to your databases in its own database on your instance. It keeps 30 days worth of previous data and stored in time series. How many of you have come across a scenario where one of your customers comes and says, my performance a week ago was bad than my typical performance? And then what do you say? Repro, right? Reproduce the problem. And then they go, oh my God, how can I repro? I don't know. How can I replay the state? Right? Looks intuitive, but these are the ways in which we provide. The Query Store, which provides and stores all this information in time series format, so you can go back, you can time travel back 30 days and figure out what actually happened across the system, end to end. And secondly, using this data that is stored in Query Store, we are now able to provide you with query performance insights. What can you do to make it better? What could you be applying? What indexes you could be applying so that your workload performance could improve? What indexes you could be dropping so that your insert performance goes better? Because if you have an unused index and you never figured out that there is an unused index in your environment, how would you know? And thirdly, performance recommendations. Right? So now you have in your pocket a rich set of insights using AI and ML techniques, learning from the millions of databases that we are operating and managing in our platform, and provide that as value to the end users, to the developers, to the DevOps, so that they can optimize not just the resources and elastically scaling up or down, but also apply those optimization to further decrease their cost and improve their end user experience, which is what cloud native capabilities are uniquely capable and should be able to provide you with this differentiated capability. So with that, I'm going to call on stage Molly. She's going to actually help demonstrate these capabilities and how these insights could be used for tuning and optimizing your workload performance.
Test. OK, great. So let me go ahead and switch to my machine. So I have a MySQL database here. As you can see, I am running a workload on here. It has a few queries that are going, and I want to better understand what is causing my server to slow down in this case, as I have observed as a DBA or as a user. So I navigate to the Query Performance Insight tab here, and I can see these are the queries that have been running over the last 24 hours, selected by average execution time. And I can see, for example, that this query in particular is taking about 28 seconds. So I can zoom in on a specific time period that I want to view, and I can see, OK, my query here is taking a good chunk of time, and I want to see, how do I improve this? My query is executing slower. Are there ways that I can improve that? So let's go ahead and go to the Performance Recommendation tab. So this will take a look at your queries, take a look at your query stored data, and generate performance recommendations that you can then directly apply on your server. So for index recommendations, it'll take a look at the existing columns that you have and see, can we add an index that'll speed up the performance of your queries? In this case, we can add carrier ID, and that'll improve the performance of your query. We also provide query recommendations. So these are query rewrite. We use established anti-patterns to rewrite your queries that'll be more performant when you rewrite them this way. So we can show an example of this. Let's go ahead and copy the original query. I can't juggle. Thank you. So let me go ahead and connect to my database here. And I will run. I will use my existing database, TPCC in this case. And then let me go ahead and run this original query. So from Query Performance Insights, we can see that this took a few seconds to run, about 20 seconds. And we have our recommendation of what a query rewrite should be. In this case, having the halving clause within your MySQL query has been shown to be less performative than having a group by and a where clause instead. So that is a suggestion that we have here. So this one took about 22 seconds to run. We can see 100 rows, 22 seconds. So let's check the rewritten query that was generated. And paste correctly. Let's go ahead and run. So this took about a second to run, and it resulted in the same data, the same result. And making sure that you have this difference in your query has automatically improved the performance of this query on your server. So the goal with intelligence performance is to really just show that we are committed to providing intelligence insights that you can then have actionable items on. So switching gears, still talking about recommendations.
So before you... So what Molly demonstrated, and just to kind of make sure you understand what is actually currently shipping in the product and what is actually in the roadmap. And she traversed very quickly between capabilities already in our platform, whereas the index recommendations, for example, it's already available. And at Ignite, we announced general availability of intelligent performance for MySQL and MariaDB. It's been in Postgres for quite some time. But now, what we are doing is taking this and taking it even further, right? Imagine that your application developers or you're a DevOps, you're writing an application and you're supporting a database at the same time, but you don't know what's the right way to query the database, right? how to best optimize your query, right? Writing that SQL query so that it performs the best on your database. And that's what the query rewrite is actually doing. And it's doing that by learning patterns and having the database context so that it knows that if you were to rewrite the same query in a different way, you are able to get a significantly better performance, right? And these are the examples where the query recommendation is currently not yet generally available, and we are looking into putting that in a preview in the coming months. But we just wanted to give you a glimpse of what we are working on in the lab so that this intelligence team is actually going above and beyond what we already have in terms of recommendations. Molly?
So switching gears to Postgres for a moment, we also have this in preview for automatic tuning. So here, the only difference between these two servers, we're running the exact same workload, exact same queries. The size and everything else related to the database are the same. The only difference is that we have automatic tuning enabled for the first instance and not for the second instance. So if we take a look again at the queries that we're seeing from Query Performance Insight based on this, let's see. Automatic tuning is essentially a parameter that when you enable it, it allows the users to in the back end, automatically tune parameters. In this case, we will be looking at workmem, which when it's at a lower value, it'll cause queries to spill to disk. So having an automated tuning value for workmem would prove valuable, as it would improve the performance of it and reduce the number of bytes that are actually spilling to disk. So if we look at the instance where it is disabled, automatic tuning is not on, it uses the default workmem value. We see, for example, this query is taking about 13 seconds to run consistently throughout here. If we take a look at Ignite, the first one, where automatic tuning is on, we will see that there is, that same query is taking, it has a 50% improvement once you have automatic tuning on. So how does this work? Why is this actually happening? Why is the query performance improving? So if we take a look at the temp table information and the workmem value, we should be able to better understand this. So let me go ahead and, thank you. Let me go ahead and connect to the second instance where automatic tuning is currently off. And if we, let's connect. So again, this will show your temp table information, the number of bytes that are spilling to disk, and then your actual current workmem value. So in this case, we can see, once it loads, these are about the temp bytes difference, the number that is spilling to disk, and our current workmem value is the default at 4 megabytes. Let's go ahead and look at the one that the auto tuning is on. Go. So automatic tuning has incrementally, what it has done is increase the workmem value here based on your server size and configuration and all that. So over the space of time, it incrementally increases the workmem value until it sees that the number of bytes different here that are actually spilling to disk is a lower amount, and there is an improvement there. So essentially, we are using machine learning algorithms to generate these optimal values for you, and it takes the pain away from the user for having to manually configure these workmem values, these parameters that once you tune will increase the performance of your database.
Thank you, Molly. How many of you have come across like a query pattern where suddenly, as the size of the table grows, increases, and then suddenly you have an aggregate or a group by operation leading that query to take minutes or like seconds, like tens of seconds, or the query degrades by like an order of magnitude, and then you're wondering what happened, right? So workmem, if you're not very familiar, is a parameter, is one of the parameter of Postgres, where essentially, if the sort is not being able to satisfy in memory, the work mem is the actual memory that is backing it to be able to sort it. If there is not enough or sufficient work mem, then all that sort has to go to disk and then have to go do that expensive random read-write operation, which will significantly an order of magnitude make the performance worse, right? So it's these scenario, for example, work mem is just one of the classic examples that we see from our own performance investigations working with customers, that it's been one of the most painful or very difficult to predict ahead of time, because the more you actually configure it, the less memory is available for other resources. So you want to be able to actually dynamically able to configure it up or down so that those queries that are happening at that particular moment are optimized to get the best performance. So this is part of the automatic tuning that we are actually started to work on. And this is not currently available, but you can expect that in the next several months, we will be rolling these capabilities, and not only just related to work mem, but other parameters. Like if you are a Postgres user, perhaps one of the other pain point that Postgres has to the DBAs, to the DevOps, is configuring and optimizing the vacuum parameters. Like if you are a Postgres user, if you're a serious Postgres user, vacuuming is perhaps one of the most dreadful tuning that you worry about or you obsess about, because if you get those parameters wrong, imagine your database is locked down, right? And that's why we are trying to apply and bring these algorithms, bring these automatic tuning, so that we can allow you to focus on writing your application and scaling your application, and not on these configuration and not on these tunings. So that was the preview of what is in store in terms of the future innovations around intelligence, performance, and going beyond recommendations to providing these automatic tuning and also automatic query rewrite capabilities so that you can get the best out of these databases. All right, so next theme is around enterprise security, right? So enterprise security starts with providing you with all the capabilities that you can use to manage security. It starts from access patterns, right, where our approach is integrating with these open source community engines, and supporting the native authentication methods, controlling the access, which is secure like SSL connectivity, for firewall rules, and also the virtual service endpoints, which we all have supported today in our products, and then protecting the data. And again, with this built-in encryption, which is already available out of the box. In our service, security is not an option. It's enabled, on by default, can never be switched off. There's no reason why you should be. And also, all of these capabilities that are not only from giving you the full control in terms of managing the security, but then also like the service comes with all these industry certifications, local and national, like global certifications, so that you can trust your data on these services. Now, some of the new innovations that we announced at Ignite and also going to be soon announcing are Active Directory support. We just announced that. And then we're going to add support for private links in December. And then finally, we are going to bring also support for bring your own key for encryption, which is also one of the most critically asked, especially in a very highly regulated industries. Customers want the ability to manage and bring their own keys. Today, it's service managed and auto-rotated. So this is capabilities that we are actually working on right now that you can expect us to land these things by end of this calendar year. Now, providing you with all these capabilities is always good. It's all good, right? But then the question is, what is the approach? Is my database secure? If I did AAD, if I manage my own key for encryption, if I did my user access control, I manage my secure password controls, is my database really secure? Can you guarantee that? No. In fact, no database is secure, right? And that's the approach we take fundamentally. And that's why, even previously I mentioned, enterprise security, that's never going to end. It's evolving and it goes on and on and on and on and on, right? Because these privacy breaches, and like the latest the Verizon report on the breaches called out that no database is immune from potentially getting hacked and the data being compromised, right? And in fact, that same report also called out that 75% of those breaches are coming from external sources. Okay, so it's always good to go behind the 75%, but what it also implicitly said is 25% of the attack vectors are coming from within the organization, which is even more alarming, right? So what do you do? How can we solve this problem? Maybe not even just, I shouldn't be telling, solve the problem. How can we provide you with methods to mitigate the risk of this problem, right? So security, there is never a solution. There are approaches to mitigate the risk. And now, providing you with these abilities to, again, inspired by these AI ML techniques, profiling these database access patterns and detecting these vulnerabilities and alerting you on those vulnerabilities as it is happening so that you can take corrective actions. Suppose you have an employee in your organization, left the organization, knew the database name, you did the right job, you changed the password of the database, he knew everything. But the database name remained the same, the user ID remained the same. And that user is now trying to penetrate and try to steal the data with the different combinations of passwords. What would you do? You need defense mechanisms to be able to detect that some malicious user is trying to hack on a known database name and the username, access to the database, all legitimate. You did the right thing to change the password, but now they are trying to see the combinations of passwords. It alerts and detects you. You get alerted right away, right? Secondly, if you have, typically your database is accessed from the US, and suddenly one fine day you say that someone from another third world country is trying to access your database. You never know. Somebody is trying to fish into your database. You get alerted on it because that's an unusual pattern, because we are able to detect that continuously, like auto-learning all the time and figuring out what is legitimate access, what is not illegitimate access, and alerts you on demand so that you can take corrective actions and you can govern the security. This is option available with a simple click of a button. It's called Advanced Threat Protection. Just click it on your portal and you start getting in those alerts over email, or also you can go to the Azure Security Center, which is the single pane of glass, to track, monitor all the security-related vulnerabilities or potential issues around security so that you can start to take corrective actions. Okay? It can also alert over emails. This is, again, the type of value, the type of approach that we take around security. It's not about giving you controls in terms of providing the defense mechanisms. Of course, you should continue to do that, but then how are you going to take it above and beyond that? That's the innovations that we are focused on and delivering that value back to you as users. Okay. So beyond these databases, we talked about a little bit on these need for these databases as you take bet on these open source databases, knowing and being sure that it will take to wherever your workload takes, so that you don't have to change your strategy, change your technology choices, do expensive refactoring midway through the journey of your workload. And that is why hyperscale is important. Hyperscale for Postgres that became generally available transforms a single node Postgres into being distributed so that you can run it across hundreds of nodes. So that resource is never a bottleneck. CPU is never a bottleneck. Memory is never a constraint. IOPS or storage, bandwidth is never a constraint. Your workload scales as you put more hardware or more resources to it. That's what makes scaling simple and easy. Right? And then not locking you in to our ecosystem saying you can only get this capability on Azure and nowhere else. This is already also available as an extension, an open source extension that you can download and run without having to pay a dime. That's our approach to open source. Our approach to open source is not just supporting open source software on our platform. It's also about contributing back to the platform and going to the roots of why customers and enterprises are choosing open source in the first place. Because they don't want lock-in. They want the flexibility and the freedom to take the choices of technologies they make anywhere they go. And that's why we provide this as an open source extension. It's fully compatible to the latest innovations of Postgres. That means it always stays current as Postgres evolves. So the goodness of Postgres comes automatically to this hyperscale. And what we provide in Azure is a fully managed experience with SLA so that you don't have to worry about all of this management. Further, we actually now extend it beyond Azure. With Arc, now you just have to bring your infrastructure, your hardware, managed by Kubernetes, and that is all it takes. You can now get hyperscale capability at your fingertips on your premises, or even AWS or Google, or whichever cloud, whichever data center, wherever that you shall so choose to take it. Right? So SQL database and Hyperscale were the two database engines, and to kind of give you a true demonstration of what this really means, like what is the manageability that we are bringing to the Hyperscale on Azure Arc, I'm going to invite on stage Lucas to give you a demo so that you can see it for yourself.
All right. Let's see, is this one on?
You have 2 minutes.
All right, there we go. All right, perfect. Give me 1 second to switch to the correct machine here. I realize we're running short on time. Let's see, number 8. All right, perfect. So what you can see here is the Azure portal, right, as you know it. But the Azure portal shows not just a Postgres that runs in your Azure cloud, it actually shows a Postgres that runs in your own data center. So we can kind of manage our on-prem databases the exact same way as we manage our in Azure Postgres databases. Now, to take a look at that, we can click into that particular resource. Right, again, this looks the same way as any Azure resource, behaves the same way. You can tag it, you can manage access control. But this is actually in the Chicago data center, outside of Azure, running on a Kubernetes environment. Now, to show you how it actually looks like under the hood, I'll briefly switch to the terminal, show you here, we have the command called AZData, which is like the Azure CLI. This shows you which Postgres instances exist, right? So we can, might take a second. Perfect, there we are. Right, so we've got our PGScale, runs and kind of, has 4 worker nodes. I can show these using kubectl get pods, right? Kubernetes CLI that you're familiar with. And now that same Postgres server group, again, shows up in Azure with the exact same pods, the exact same worker nodes as it does on a Kubernetes cluster. Now, there's a lot of benefits here, like, for example, metrics, right? We can kind of go into details here. Split up the kind of, like look at the CPU usage, for example, over time. I've run a couple of workloads earlier today. I could look at, for example, the last 4 hours and kind of, see here the workload over time. I can split that by the individual worker nodes, kind of see, like underneath the hood, all the details if I want to. And again, I see that in the Azure portal the same way as I would say for a hyperscale server group that runs in Azure. Now, let's say I want to scale this out. So the nice thing here is you can actually scale this from, the like very small scale, few worker nodes to all the way up to 50 worker nodes, right? So here in this demo, if I want to go up from here all the way to 50, right, I can save that. Now behind the scenes, we're essentially using the Kubernetes resources, right? So these are existing servers that are running, where we're essentially allocating kind of Postgres pods and kind of bringing them online. And then, as we can see here, in the data rebalancing tab, we're actually moving your data into these new pods. So essentially, like, whilst, this is happening, your application is online, you don't have to change anything. You can just scale out in your own environment without limits.
Thank you, Lucas. So this is like bringing you the power of the hyperscale, a managed experience with backup, recovery, all of this capability on your premises, on your infrastructure. So we are really very excited about this preview. So if you are interested, which I'm sure you are, we'd invite you to sign in, and get onto the queue. We're going to be gradually opening it up in the limited preview. and are really interested to kind of learn and hear from your feedback. I'm already in 5? OK. All right. The last section is really about this Azure integrations and making it productive, right? And this goes to all the way from how are you going to use and leverage the Azure ecosystem, and how are we integrating it with open source databases, be it using Azure Data Factory, through which you can run your complex ETL pipelines without any code, and use Postgres database as an example to sync. Like it was always supported as a source, but just recently we added support as a sync. So you can bring data from anywhere across all the 80 plus connectors Azure Data Factory supports, and put that data and bring that data back into Postgres and run dashboards and et cetera. And similarly with Power BI, one of the critical factors of Power BI is like what we had support for is pulling data from the data and building those cubes inside your desktop. That, of course, has limitations. As your size of the data increases, think about the kind of hyperscale databases that you will be now able to create on Postgres. Copying the data from the database and then running your BI queries is unusable. So therefore, with Power BI Direct Query, you can offload, you can push down the query all the way to the database. So now that means you can run your complex dashboards again on tables with billions of rows at ease and visualize that data. So finally, so those who are interested, I know we've ran out of time, but if those who are interested, I want to show you a demo on how all these integrations actually come into play. But since we ran out of time, I want to talk about also, so what's next? What are we going to work on, right? You've heard some examples of things that we're working on, but our vision going forward is continuing to innovate in the platform, right? Be it in terms of improved performance, reduction of latency, manageability, cost resource optimization, because the same right scale report that I talked about, where I said 53% of the users are currently using DBaaS, and DBaaS is the top workload, they also cite cost management and optimization is the #1 concern that you have. So we are going to be innovating, and we are going to be working hard on your behalf to bring the cost optimization controls and methods so that you can govern that better. And of course, on the database platform, its security continues to become of paramount importance, never stops. But so will intelligence as well, giving you capabilities on the cloud that you would never otherwise get elsewhere. And then, of course, our strategy is very much built into the core community, where we are innovating around it, right? And innovation around it is where the innovation value around intelligence, security, et cetera, comes into play. That value is created in the platform, not inside the database engine. So that you get the freedom of running the true open source versions of these engines anywhere, so that you're not locked into the database, our database engine. And a differentiation and our value creation is going to be around it. And then you heard about our Hyperscale MySQL. It's a very strategic part of our game plan. And similarly, we're going to be working on enabling Hyperscale for MySQL as well. Right? And in fact, we are working on it. So stay tuned for us to be bringing MySQL Hyperscale to the market. And then integrations. It's one of the foundations, the value. It's not just about the data. It is about how do you harvest and bring the best of the Azure ecosystem and get that best of the Azure ecosystem to these open source databases. So in a nutshell, these open source databases are a very strategic part of our data portfolio because we are listening to you. And our goal is to meet you, our customers, where you are, and not sell you technology. We sell you solutions. We want to provide you solutions. Regardless of the technology choices that you make, we have you covered across performance, security, intelligence, manageability, all of the above. So I hope you trust us, and I'm sure after this, around these innovations, we are very eager to get your feedback, because your feedback is what drives our innovation agenda on what problems that you have that we can solve for you. But we are positioned very well around making these open source databases the best in class in the whole industry. So thank you for your time. And if you have time left, I do want to show you the integrations as well. But I want to be respectful for those that came for the 45 minutes, and now I know we have 5 minutes well overpassed. So thank you. And if there's any questions, we'll also be here. More than happy to field those questions. And always, again, don't forget to fill in the evaluations. Very important to hear your feedback so that we can do better next time. Thank you.